Alright, hello everyone, my name is Jacob Schuster. I'm the main team lead for the Material Atlas Capstone 2 project, along with Owen Wen and William Duran as members. And today I'm going to be talking about what we were working on and, more importantly, what we were able to accomplish during the semester. Let's get right into it. So first of all, what is Material Atlas? A little bit of motivation. So currently, collaboration between material scientists and the people actually using the materials, so the architects, engineers, project owners, etc., is very low. So in other words, the knowledge across disciplines is very fragmented. This means that the correct material isn't always chosen for each application, which can lead to unnecessary monetary and environmental costs in many cases. Material Atlas is designed to be a fully online and open database to bridge the gap between research and application. Our use of AI and graph databases to visualize materials means that it's very easy for just about anyone to get value from the website. These are a few of the requirements that we set out at the beginning of the semester, and later on I'm going to talk about how we were able to hit on each of them. The first one is AI integration to expedite material uploading. A problem with many other material websites is that it takes an incredible amount of effort to add an entry to the website. So what ends up happening is that most material researchers don't bother to use it because it's a lot of work. So the angle we try to take, we wanted to integrate as much AI as we could to offload the majority of the manual labor from the researcher to the AI. And we hope that by doing that, we can get more submissions on our website, which will make it more valuable, since data is everything. And then the graph database exploration, we wanted to make it very easy to see the materials as not only their attributes, but the relationship to other materials as well. And the way to model these relationships, we figured, was by building everything in a graph database. And I'm going to talk more about that later. User authentication, we want users to be able to register for an account and log in. Material comparison page. So if you select materials, there should be a page where you can compare their attributes and view graphs plotting each material against each other. And then the last 2 points, scalable architecture. We are expecting a considerable number of users in the future. So we wanted to design all the components of the app, like the database and the authentication system and the AI, to scale with users. And then lastly, design everything with deployment in mind. The project is going to get deployed, so we need to choose technologies that are conducive to deployment and design with it in mind. All right, speaking of tools and technologies, here are just a few of the technologies we used. We used Python and LangChain, scikit-learn for the natural language processing and AI integration. And then for the front end, we used TypeScript, Next.js, and Sigma.js for the graph visualizations. And then for the database, we used Neo4j as a graph database. Okay, going to the first point, AI for material uploads. If you go to the website and you upload a material, this is a page you'll be greeted with. We have some instructions on the top. Upload a research paper to get started. Our AI will extract the information from the paper and pre-fill the form for you. Once completed, click the submit button to add the material to the database. So you actually have two options. You can either upload the information by filling out the form manually, or you can drag the paper into the box and the AI will pre-fill as many elements as it can and then leave you to do the rest. And in our experiments, the AI was actually very good. We found it was able to usually fill around 70% of the information on the form, which can reduce a tremendous amount of time. And the way we do it, you upload a document, we parse out all the tables and the images. We are using GPT-4 Vision, so we generate summaries of the images and embed them for a vector retriever using LangChain. And then we ask it questions about, based on the content of the paper, we ask it questions to better pre-fill the information in the form and output it as a JSON schema that we can simply upload to our registration form. Okay, moving on to the graph exploration. On the bottom left is an image from our Neo4j console showing you have a variety of nodes and relationships. Right now we're only testing with a few materials on the website, but as you add more, this will obviously grow a lot more and you'll be able to, you can already see the relationships forming, but it'll be much more prevalent in the future. On the top right, you have a screenshot from our website. And what you have here, this is a page when you browse materials. So you have a collection of materials, each material is a node, and they're actually colored based on the type or the area of the research topic. So you can see we have sustainable urban area biocement, marine infrastructure, and living materials. And the way we generate these labels is completely unsupervised. We have an input in our material upload form for an overview. And what we do with that, we embed it using a large language model. Specifically, we're using OpenAI Ada 2. So we get those embeddings, we cluster them using k-means clustering to find the centroids. And then for each centroid, we get its label based on, we take the embeddings of the surrounding nodes and average them out to find a label that's representative of the population of that centroid. Then we give it colors and we graph it. And the way we graph it, we bring the embeddings down into 2 dimensions using a TSNE transformation. So yeah, that's what you have here. I think it's really cool because if you're looking for a material for a specific application, you really know where to shift your attention. So you don't have to look through materials that aren't relevant for your application. And then on the top left, this is a view you get if you click on material. And this is really the power of our graph database, that you're able to see all these visualizations. And a lot of it comes for free just by encoding the data in that way. So here you have the material. You can see it's associated with mixes. Those mixes are associated with elements. And you can actually chain graph queries. There's more on this in the demo, but if you click on the material, you can see the mix that's associated with it. If you click on a mix, you can see the materials and the elements associated with it. And you can keep changing these queries, and you can really gain some incredible insights, and it can be a really efficient way to search through the database. So yeah, that's it for now. We all had a ton of fun during the semester working on this project, and it was a great learning experience. I knew next to nothing about graph databases before I came in, and I definitely know a lot more now. So yeah, it was a great learning experience, and I'm excited to see where the future of the platform goes.